Hello fantastic people, I hope you are doing great. If you feel you have a little bit of programming knowledge and you know Unity a little bit, but you don't have enough confidence to create your first game, you are in the right place. Today we'll create this shooter game together from scratch. So as you see, I can walk in all the directions, my character can shoot, it is looking at the mouse all the time, and every some time there are spawned enemies which try to get me, and once they do get me, they kill me, and I have to press R to restart the game. Dead. I hope you're excited. First thing we have to do is to create the project. So I'm naming my project just simply shooter game, and I'm selecting the 2D URP. So Universal Rendering Pipeline gives us a little bit more tools to make our game beautiful. We're not going to use them in this episode, but if we decide to make it a little bit nicer later on, we will not have to do any extra configuration. So you can go with this one, or you can also go with pure 2D core template, which will be also fine. Now let's click create project, and our project has been created. So first let's start by tidying up a little bit. So URP created a little bit of files for us, so let's create a folder for them, URP, and let's put there the universal rendering pipeline asset and the settings. Awesome. Now the first thing we have to do is to import our assets. So I'm creating another folder for my sprites, and then I'm clicking import new asset, and then just selecting the right folder and clicking on the file. Now you can find those assets in the description, so you don't have to worry, you can follow everything step by step, so yeah, you don't have to worry about anything. Now as you see, if we open this file, all the stuff is in one big file, so we have to somehow split them into multiple sprites. Now to do that, we have to change the sprite mode here on the right from single to multiple. Then we click the sprite editor, and we have a question if we want to confirm the settings. We want to, so we want to change the sprite mode, and the new window pops up. Now we have here a small drop down with small, I'm not sure you can see it, with small text slice here. We select the type automatic and just click slice. Beautiful, everything sliced nicely for us. Now if we click on the different sprites, we can see that in the middle there is a small blue circle, and that is so-called pivot point. All the transformation in game, so all the scaling, moving or rotation, is happening around this particular point. So while it doesn't matter for grass, we have to make sure that it is in the right place for our characters. So we want the character to rotate around their body, around, so somewhere like in the middle of the head, I'd say. Okay, so as you see, I adjusted that, and now I just click apply and close the window. And as you see, straight away I have several beautiful sprites. So now I will change the camera to be squared. To do that, I change the window from the scene window to game window, and then in the free aspect place I change it to one aspect. Now I added it manually, so if you don't have it, you can just click the plus button, select aspect ratio, and just write 1 1 10 10. Just important that both those numbers are the same. We just select that, and you see straight away our game camera changes to be the right size. Now I go to the scene, and as you see, like the border of the camera straight away indicates what is the size of the viewport, so basically what I will see. Now because of that, I can start placing my grass. So let's just make sure that it covers everything nicely. So here a small tip from my side. So you see I created the grass sprite round, and because of that, because of the irregular edges and because it's round, I'm able to place them one on the other, and it kind of seems natural. So when you look close, you cannot really see the borders. So this way is slightly better. If you, I mean, there are use cases where obviously tiles are much better, but if you don't use tiles, it's much better to have round sprites for ground and stuff like that than squared. It's much more difficult to work with squared sprites. Now I have a grass, and it would be annoying to work with it all the time. Because, you know, I will place my character, then I will accidentally click the grass instead of the character, and then I will put the wrong put the component on the wrong place. So to avoid that, I create a simple single empty game object and name it ground. Now I put all the assets, so all the grass things, to the empty object, and now on the left, you see there are those small icons. If I click on the small hand with the finger like that, suddenly the sprites are unselectable, and it's awesome. It really helps a lot. So that's first thing. Then, because it's background, I don't want it to cover any other sprites, so I will adjust their sorting layer. So basically, sorting layers are responsible for telling what will be rendered where. So, you know, it gives us this extra option to manage the order in which things are drawn on the screen. So now I selected all the assets. I don't have any other sorting layer, so I click on Add Sorting Layer, create new one, and name it background. Now I'm moving it before the default. The default sorting layer is basically the one that is applied by default when you drag and drop something onto the scene. So we are done here. Then I'm once again selecting all the grass assets. I think I could actually rename them. Yes, you see, beautiful. I selected all of them and just placed the name for one, and suddenly they all change name. Amazing. Now I'm changing the sorting layer to background. What happened is basically in URP, the sprites are affected by 2D lights. So here I have a global light 2D, and by default, you see there is this target sorting layers, and only the default is selected. So what I'm going to do, I'm just going to click all. Oh, beautiful. Suddenly the glass is light or bright. Awesome. So it's time to create our character. I'm drag and dropping the sprite onto the scene, resetting the transfer, so it's in the middle. Now you see I have some gizmos which are annoying. So what I can do here on the right, I have this small button. If I click it, the gizmos disappear. So this is a very useful feature. I scroll up a little bit, rename the sprite from assets 3 to player, and I add the rigid body to the component. Now be careful, do not add accidentally the rigid body, because it will not work. So rigid body 2D. If you're not aware what rigid body is basically component that allows us to apply physics and collisions and all this type of stuff to our game objects. Now I have the rigid body 2D here. What I have to do, you see there is this setting gravity scale. I have to change it to 0 because obviously our game is top down, so I don't want the character to start falling down. So if you see that your character starts falling down, you probably forgot to change this one. Beautiful. I have that. Then obviously we'll want to apply collisions to our character, so you know, when the enemy touches, we want to die. So we have to add also the collider. I think the best one will be the Circle Collider 2D. Once again, be careful to do not add the regular colliders. So if you have a look at colliders, you see there is Box Collider 2D, Capsule Collider 2D. So we are interested only in the 2D versions. If you add a regular one without 2D, nothing will work, the collisions will not work, and it's very silly mistake. It's very hard to find. To be fair, when I was preparing for this episode, I've done literally that and I was debugging and wondering what is happening. So yes, just remember about that. Learn on my mistakes. Okay, so I have Circle Collider 2D. Now we'll need to enable gizmos to see how big it is. Let's move our character to the side, and you see it's a little bit too big, so it wouldn't be fair to react like that, because if our enemies touches us from the side, then you see they will kind of do not have to really touch the character. So let's decrease it to something like that. In general, again, small game design tip, it's much better to be a little bit more forgiving for the player. So when you make colliders for enemies, it's better to make them, for example, easier to hit, easier to shoot. But when it comes to the player, it's a little bit better. It gives a little bit better feeling when the character is slightly more difficult to hit. So if you have to make decision between that and that, smaller is generally better in this case. So I have my collider, and we are ready to start writing our first script. So I'm creating the folder for the script, beautiful, and I'm creating first C# script and call it player. Let's open it up. Okay, so we have straight away here some stuff happening. We can remove those two, which are added by default, but we won't need them. Now, we'll need those two, but first let's have a look from the top. So public class player, that's how we called it. Extending monoBehavior. MonoBehavior is basically a class provided to us by Unity Engine that allows us to attach scripts to game objects. But not only that, it gives us several so-called callbacks, so things that happen in the life cycle of the object. So basically when game object appears in a game, there are several things that happen one after the other. So we have things like awake, on enabled, start, update, fixed update, on destroy, many different ones, and they serve different purposes. You can look into documentation. For now, let's just focus on the simple one, and yeah, that will be enough for us. So we can remove the comments, and let's start by creating a variable to store our rigid body 2D. We'll need that because we want to apply, obviously, movement to our character. So that's here. Now, by default, the rigid body from the character is not stored in this variable. We have to put it there. Now, to do that, we can use getComponent method. So we take rigid body variable and use the getComponent method with those nice angled braces or brackets. And in between them, we have to put what type of the component we want to get. So here we get the rigid body 2D. And just to let you know, if game object doesn't have that component, what will happen? This will return null. So you may have some unexpected behavior. Please remember about that. So this will ensure that when the object starts its life cycle, so before the first update, we'll get the rigid body. Now, here, let's take care about movement. So we have two parts of the movement. First one is looking at the mouse, and second one is moving in all the directions. So first, let's rotate our character towards the mouse. For that, let's create a separate class first. You will see in a second why. Let's call it mouse utils. So what is happening? Basically, when we move the mouse across the screen, when we ask Unity what is the mouse position, it will give us the mouse position in the screen space. So basically on the screen, not in game. And this is a little bit problematic. So we have to make sure that we convert this screen space to actual like scene or so-called word space. Oh, this is strange. It didn't generate anything inside the class. Okay, let's fix that. Public class mouse utils. This is interesting. Now, let's create one static method. If you want to learn a little bit about statics, I will link a video somewhere there. So public static returning vector2, because we are interested in the mouse position in the 2D space. And now let's call it get mouse position 2D. We need to import Unity engine because we'll be using the vectors implementation from Unity engine. And here let's do the magic. So return camera. So this is just general camera class, which gives us a lot of information about the camera. And among those information is information about the main camera. So I'm getting the main camera from the camera class. And then here it has the method called screen. Yes, screen to word point. So this will convert the given position on the screen to the word position. Now what we have to do is to get the mouse position, and we can do that using input class and its property mouse position. And this will give us beautiful position. Now let's get back to the player and let's rotate the player towards the mouse. So we do that using transform. So transform is a game object, it's a component on all game objects. So you see whatever we create here, even if it's empty object, like I created here the ground, it always has transform. So it has some information about the position, it has information about rotation scale, and so on, so on. So that's this one. Now update, transform, and up. So basically what we'll do is basically, the transform stores the information about the direction in which it is pointing. So if you have a look at our sprites, once again, our character is looking up. So when we rotate it, we want to make sure that we point up. So the up direction of the sprite, so the top part of the sprite towards the mouse. So wherever mouse goes, the up part of the sprite goes too. So that's the reason we have here the transform up. Now we want, and here is small formula to calculate the direction towards something. So basically what you have to do is to subtract from the destination the origin position. So our destination is the mouse position. So we use the mouse utils, get mouse position to D, right? So that's the place where we want to look. And where we start, that's the transform position. Position, beautiful. So that's the position that will give us the direction. Now what we try to do, we have small error because we try to subtract vector 3 from vector 2. We are not interested in the 3D space, so we can cast the transfer position to vector 2. So that will give us vector 2 minus vector 2. And then what we can do is to normalize them. So normalized vector, this is pretty interesting. You can watch a video about it in one of the tutorials, which I will link there if you want more details. But long story short, vectors can have different length. So they have direction, right? And they have different length. And this is not good for multiplying stuff and so on, because obviously yeah, different length will give us different result. So what normalization does is basically changing the length of the vector to 1. So it doesn't matter in which direction we look, the magnitude, so the length of the vector will be 1, but the direction will be untouched. So that's what normalization is. So we want up to be the destination minus origin normalized. And you will not believe, but that's all we need to rotate our character. Let's test it out. Let's make sure that our player has actually the player script attached. Beautiful. And as you see, our character is looking at the mouse. Walking is a little bit simpler, so let's get back to our script. Now, first thing we need to do is to create variable to store our input. So it will be vector2 because we want horizontal and vertical input. And now in the update method at the very beginning, what we can do is to store in the input new vector2 with two information. First one is the information about horizontal input and get access vertical. So basically what the get access does, it basically searches in the input manager. Here we have information about all the buttons, right? So for example, here we have horizontal and vertical access. And this is basically information about like continuous input in certain direction, right? So here we have access horizontal, so to the sides. We can use left or right button or the A or D. And similarly for vertical, we have down or up and S or W. So if we use this information here, what we can do, we can get the X-axis and Y-axis. So we have the input in two directions. Awesome. Now we want to move the character using that input. So for that, we'll need one more variable. This time, let's make it public of type float and let's call it speed. Basically, the reason I'm making it public is that whenever I create a public variable, it will be visible in the inspector. So I can manually insert here number and then I can change it. I don't have to go back to the code to do that. Back to the script. And now let's actually move our character. So once again, we want to do that on the transform. No, I'm wrong. Not on transform. On the rigid, we want to do it using rigid body. So first we use the rigid body. Then we set its velocity. So basically how fast the character is moving. And what we do input normalized times speed. And this is really it. This is literally all we need for our character to walk. Let's test it out. Yay, awesome. Everything works as expected. Beautiful. So if you feel that your character is too quick or too slow, you can always adjust the speed. Awesome. It's time to add shooting. Okay, so let's make a little bit more space. Get back to our sprites and let's drop the bullet sprite into the sun. Now we want to give it rigid body as before, so rigid body 2D. We want to give it small collider. It can be box collider. With such a small items as this one, really other types do not really make sense. So we rename it to bullet. Awesome. And now it's time to write a bullet script. So scripts, new, create bullet. And let's open it. Or maybe first let's assign it to the bullet object. Awesome. Now we open the script And once again, we want to store the rigid body. Let's grab it in the start method. Awesome. And now in the update, we'll want to apply certain speed in the bullet direction all the time. As easy as that. First, let's remove those ones. We don't need them too. Let's remove the comment, and then here, let's do it this way. Rigid body, velocity equals, and now transform up. So the direction in which the sprite top is pointing. So this gives us nice information about the actual direction, and we need to multiply it by speed. Now we don't have that variable. Let's create it. And once again, public. So public public float speed. And awesome. Why is it? Is there a reason why it is grayed out? No idea. My idea is striking today. So public float speed, and this should be enough to have the bullet flying. Now let's get back to the scene and let's set the bullet speed. On the bullet object, we set it to, for example, 12. Awesome. Now we turn it into the prefab. So prefab is a special type of object which is like a template. So if we know we'll be using an object multiple times, it's a good idea to turn it into prefab. This way we don't have to set it up every single time. We don't have to somehow construct it and at runtime add components and stuff. Then we just store exact state for later. And as you can imagine, we'll be shooting a lot of bullets, so we'll need that. So we can remove this game object from the scene. As you see, it turned blue and changed a little bit the icon to indicate that this is actually a prefab. Also, you see there is this small arrow that you can click to enter the prefab mode. So here you can, whatever you edit now will actually update on all of the prefabs. Let's get back here. Let's remove it from the scene. And now let's start shooting. We get back to the player script. Let's create. I'm really interested why this is gray, but let's get back to the player and let's create shoot method. Private void shoot. In the shoot method, first thing we will want to do is to instantiate, so to create the bullet. To do that, first we need the reference to the bullet prefab. So we create a variable public game object bullet prefab. Now we copy the name and in the shoot we instantiate the bullet prefab. Now we'll need a position where we want to do that, right? So we don't want it to be at center of the character. That wouldn't make sense. So what we can do, under the character, we can create empty object and call it gunpoint. Now, as it is very hard to see, because obviously it doesn't have any sprite or anything like that, we can add an icon to it. So here we have this icon next to its name, and we can change to beautiful small icon and then drag it to the top of the gun. Awesome. Now, in the player script, we need to create a variable for that too. So public transform, because we are interested only in position, we don't need to store the whole game object. Transform gunpoint. We save it. We'll have an error, so it will not allow us to set it. So let's comment this one out to do not have any errors. Now, let's get back to Unity. And let's set those two fields. So first we set gunpoint, and then we grab the prefab and drag it into the bullet prefab. back to script and instantiate bullet prefab at the gun point position and at the transform rotation. So we want the bullet to be rotated exactly the same direction as the player. Now we need to shoot the projectile. So in the update method, we check using the input class if get key down. If a key was pressed, we'll be interested in the fire one. So once again, you can check what's this exact key in the input manager. So let's check fire one. That's joystick button 0. So it will be left mouse button, I believe. Awesome. Let's get back here and now just invoke our method shoot. Let's test it out. Whoops, I used the wrong method. So we see an error in the console, right? So when I was clicking, the bullet was not shot. So what happened is basically in the script, instead of using the get button down method, I used the key down. So the difference between those two is that the button down checks uses the name from the input manager, but when let's just to give you example, but the key down requires to provide the actual key. So for example, key code letter A, right? Or key code space. So the particular, not mapping for the button, but the actual button. So let's remove that. And now everything should be working. Beautiful. We are shooting projectiles. Awesome. But as you see on the left, we are creating a lot of bullets and they are not getting destroyed. So let's handle that now. Here the fix will be pretty easy. So we get back to our bullet script, and in the start method, what we do, we say Unity to straight away destroy the bullet. So destroy this game object. So if you see something starting with with small letter, it's generally, not always, but generally like this particular instance. So the game object, or in another script like transform, it's not the transform class, right? But rather the particular instance belonging to that particular mono behavior. Now, this would destroy the bullet straight away, so it wouldn't make sense. We wanted to give a little bit of time before that happens, so we can set, for example, 4 seconds. And this is enough because we have pretty small game space, right? And you know, like the bullet traveling through all the level will take less than 4 seconds, definitely. So we are safe. We are safe. Let's just double check that it doesn't disappear before it goes through the whole level. Yep, it's going through the whole level. Beautiful. Awesome. And we see that the bullets are disappearing. Awesome. Now the second thing, the bullet looks not that interesting. So let's get to the prefab. So I'm double clicking on the prefab and I will add one more component, and that is trail renderer. So this will give us this nice tail at the end. Now our sprite is very small, so we'll have to set the width of the trail to something very, very low, like you see 134, and then add the key at the very end. So right mouse button, add key, and drag it to 0. This will basically decrease the size of the trail all over time. And now when it comes to the time of the trail, we want it to give very short time, something like half a second. And now you see what's happening. It's pink. And the reason it's pink is because by default it doesn't have any material. Materials are a little bit complex thing, but in the simplest way to put it, materials are information about how to display something. like they contain information about shader, which is even more complicated subject. So let's just stop there. We won't need that much information. For the trial renderer, we just go to the materials section and select existing material of something like, you see the default lead material. So this is literally just a white square, and suddenly everything will work as expected. Now we want it to be behind the bullet. So as our bullet is in the sorting layer default and order in layer 0, what we can do, we can make the trial renderer to be in order in layer, its order in layer to be -1. This way it will be behind the actual bullet. So let's shoot now. Let's see how it looks like. Awesome. Great. So I think it is going a little bit too slow, I mean the bullet. So let's change the speed to something like 15 and maybe decrease the time of the trail to something like 0.3 and maybe even make it a little bit smaller. Let's see how it looks like now. Awesome. This is a little bit more dynamic. Love it. Thank you. Okie dokie. Now it's time to start creating our enemy. So a little bit of setup first. We drag and drop the enemy sprite. Awesome. Then we add to it rigid body 2D. We add to it, we need to make the gravity scale 0, and I think I left the gravity scale on bullet, so it would be traveling faster down than up. Prefab bullet and the rigid body, yes, gravity scale 0. Awesome. Now let's have a look at our enemy. Let's rename him to enemy. We have the rigid body with no gravity applied to it. Now let's add collider 2D. Here the circle collider will be good choice. Let's zoom in a little bit and decrease its size. I think that will work. Now it's time to start the enemy script. I'm going to the scripts folder and creating the enemy script. Beautiful. I will assign it to the enemy and now open it. Okay, traditionally first we do a little bit of cleanup. We store the rigid body. Then we'll want a public float base speed. So this will be set from the inspector float. Awesome. Maybe let's set it from the inspector. Now let's create another variable, this time private, for the actual speed, because we will want the speed to be a little bit randomized. You know, it would be boring if all the zombies would move exactly the same speed. So what we can do here, we can, at the very beginning, when the enemy is created, set the speed to be base speed times, and now in the brackets, 1 plus random range minus 0.1f to 0.1f. Now what will happen here is this random range will give us number between minus 0.1 and 1, right? So can be 0, could be -1, could be minus like 0.05, and we'll add it to 1. So this multiplied by the base speed will give us a little bit less, like up to 10% difference of the base speed will be assigned to the speed variable. So that's how we'll achieve the different speed of the enemies. Now in the update method, we want first the enemy to always look at the player. We'll do exactly the same trick. So as we remember our magical formula, destination, so it will be, we know we need to store the reference to the player. Now I will show you another way to get the reference. We can create a variable of type game object, or maybe even specifically player. And in the start method, we can assign to it a result of a method find object of type player. This will literally look for the hierarchy and return this particular component when it finds it. So you have to be careful because it will return the first one it finds. So if you would have multiple players, this would return the first one. And it's also pretty bad idea to use that for a bigger game with huge hierarchy and so on. It will be pretty slow, but here it's pretty fine because we have just few objects, so not much problem there. So we want destination minus origin. So here we have the player transform position minus transform, so enemies position, and the normalized. Oops, sorry. It's because of the missing bracket. Normalized. Fantastic. That's all that we need to make the enemy always looking towards the player. Now we want the enemy to move towards the player. So to do that, we can do rigid body velocity. So we set the velocity of the enemy to, and now this will be pretty fun. What we do, we use the transform app, so we know in which direction the enemy is looking, and we know it is looking at the player because we just set it one line before, right? Fantastic. Now we multiply that by speed, and seriously, that's it. We have an enemy that will follow our player. Let's get back to Unity and let's set the speed on him. So our player was 5, so let's make him slower, something like 2. Whoops, we forgot to set the reference somewhere. Let's see what happened. Rigid body velocity. Of course, in the start method, we did not grab the rigid body to the bar. That was the problem, but it's fixed now. So we get back to Unity, clear the errors, and run the game. We have the enemy following the player. Now nothing crazy will happen. He will just, try to get to us, and once he will just stand here. So yeah, this is not what we want. We want the player to get killed, and we also want to, whoa, this is amazing. And we also want to, you see, ooh, that's what happens with physics. Beautiful. So it's time to kill our enemy. For that, we go back to the scripts, this time to the bullet script. We add a method which is called void on collision enter 2D. Once again, be careful because there are also the versions without 2D and this will not work. So we get that, and as you see to that method, we have passed one parameter, which is other, which is basically information about the collision itself. From that we can get information about the object that collided with our bullet or that the bullet collided with. So what we can do, we can first, how we can determine if the object that we hit is enemy. This is pretty simple. We create a variable in which from the other collider, because that's the object that contains information about the actual collider, we can get the component of type enemy. And why is that? Or maybe what will it give us? Basically, as I mentioned before, the get component returns null if the component is not found. That means that we can test this way if the thing that we collided with is the enemy. Basically, if this will return null, that means it was not enemy. But if it was not null, that means that was enemy. And what we can do then, we can just destroy our, or maybe let's do it differently. Let's create a method on our enemy called die. Be careful, this has to be public because we want to call it outside the other script. So we want to call it from the bullet script, not from the enemy, so it has to be public. Here what we do, we destroy the enemy. As simple, as easy as that. In a moment we'll add to that the particle effects. Now I just go back to the bullet, enemy, die, and beautiful. Let's see if it works. Yay, awesome. But we also should realize that we should also destroy the bullet. So once the bullet hits the enemy, we have to also destroy it. But actually, whenever it collides with anything, we should destroy it. So let's just move it outside the if. Beautiful. That will work. Now the next step will be to kill the player when the enemy touches it. So here we can create in the player method called public die. We'll also destroy game object, but there will be some other actions we want to do, and we, for example, want to show the message that please press R to restart the game. So what we can do here, we go back to Unity and we add new UI element text mesh pro. Now this requires external package. So what we can do, we can just click the import TMP essentials. Awesome. That means we now have that text mesh pro installed. This is basically a package that allows us to create easily very beautiful text. So we scroll out a little bit. So the reason you see this so strangely, so you see our scene is over there very small, and here we have this huge square which seems to be completely out of space. That's because Canvas works slightly differently. Basically, it, depending on the setting of the render mode, it will behave differently. And here in the screen space overlay, it's basically out of scale because it's not aligned with the scale of our game or the scene, but rather the full screen. But we don't have to set there anything. We don't have to worry about the scaling. Everything will work perfectly. So we select our text. Let's rename it first to reset message. And then here you see we have pivot and anchor presets. So basically we can set in the UI, because this is obviously UI layer, so it's on top of our game. So you know, all the buttons, inventory, health points, and all the stuff would be on the canvas as the different canvas elements. So now if we want to place them in relation to certain part of the screen, so as you know, for example, if you have a health, right, and you want it to be right, you cannot set it to be on, I don't know, 400 pixels from the left. You want it to be certain distance from the right top corner. And to do that, you can use the anchors. So for example, here we can select the bottom one, right? So this changes the anchor to the bottom. And now, depending what you press, right, you have also Alt button and Shift button. So they do some extra options. They change the, so the Shift changes the pivot. No, sorry, Yes, the shift also changes the pivot point of the element, and alt basically moves the element as well. So we can we can press alt and shift and click the button, and we'll be sure that it will be in the middle. We may want to have it stretched, so for example here, and that, I think that will do it. Then let's make it bold, let's make it uppercase, let's enter the message. So press, whoops, sorry, change the keyboard, press R to restart. Now we can auto size it to make sure that it takes all the screen, and let's make it in the middle, so centered. Just to let you know, there are some other nice options. For example, we can add outline. So for example here, yes, this will be amazing because this way it will be a little bit more visible in game. You see, awesome. Now we don't want it to be visible at the very beginning. So what we can do is here on this component on Text Mesh Pro, we can disable that. So that will make it invisible by default. Now we'll go to the project settings and input manager, because we need to set the R key as a reset button. To do that, we can copy any of the buttons that are like, you know, just press, like not the continuous ones. So for example, not the ones that, not the access ones, right? So for example, jump. What we can do here, we can just duplicate it, change its name to, for example, reset, change the key to R, and I think that's it. Yes, that should do it. Now what we do, we get back to our script, and when the player dies, we want to enable the text. To do that, we'll need the reference to the text. But this again doesn't make sense, right? To store it or anything like that. So we can once again, because we have just one text, and this is very important. If you would have, for example, HP displayed somewhere or score or something, you couldn't do that. So it would be better to have, in general, it would be good to have UI completely separated and stuff. But here we don't worry that much about the good practices. It is more about creating first game quickly and without complicating too much. So what we can do here to get the access to the text we created, we can use the find object of type TMP text, which is basically the Text Mesh Pro text. It's one of the classes that comes with the package. And now we can just look for the enabled property and set it to true. So when the player will die, basically that text will be enabled. Now we go back to the enemy, and once I think we could actually, yeah, we can keep it on the player. So let's once again add the onCollision enter method, void onCollision enter 2D method, and once again let's check if what we collide with is enemy. And if it is enemy, so if the enemy script is not null, we simply die. And this should do it. So we can shoot, it works. Let's restart it. We died and we see this message, which is awesome, but we also got an error. And this is very interesting error, because basically what is happening on the enemy, we store the reference to the player. Once the player dies, this is a little bit problematic because we don't have anything to walk towards anymore. So in our update method on the enemy, we have to make extra check. So we have to check if our player is not null. No, sorry, that's how the variable was stored. here, and let's test it once again to make sure we got rid of the errors. First, let's clear the console and start. Yay! No errors. Fantastic. Okay, so at this moment we have almost everything. Let's add resetting the game. So for that, let's create another script and call it maybe game resetter. Let's open it, remove the unnecessary stuff, and the script will be pretty simple. I think resetter should be press double T, right? No? Let's keep it that way. Never mind. In update, we will check if the button has been pressed, so get button down, and as you remember, we created our new button reset. Now, if the button has been pressed, we will use the scene manager, which is another class provided to us by Unity, to load a scene. Now, to load the same scene, we can do it multiple ways, but let's go with scene manager, get active scene, and name. And this will reset the game. Now we could check here also if the player is dead, but let's assume sometimes maybe for some reason you want to reset the game while playing. You have a bug or something, you're getting stuck, or you get the point, I think. Now we can assign it to our reset game message, for example. And let's test it out. So we kill the enemy, press R, and the game restarts. We kill the enemy, press R, game restarts. The enemy kills us, I press R, game restarts. And yay, beautiful. Okay, so the resetting works. Now it's time to add spawning. I need to create an empty object and call it spawners. Now let's reset its position. And magic. If I press F, it will zoom to that object, so pretty nice thing. Now inside of it, I will create an object which I will call spawner. It is empty object. I will just add icon to see it, and I will move it to the side. So outside the camera, because I want the enemies to spawn outside the camera. Now I can copy paste several times. So for example, for here, then maybe let's copy them, paste them on the other side. Then let's maybe grab this one, paste it here. Basically, I'm making the points from which the enemies will be spawning. So 3 here, and maybe 3 at the bottom. That should be more than enough. Now we have to write a script to spawn the enemies. Let's create a script and call it spawners. I assign the script to the empty game object, so to the parent, not to the individual ones, but rather to the parent. Oh, I see it didn't appear. Let me try again, and just let me double check on the objects if I accidentally didn't add to any of them. No, all good. So I have it here. I open the script, and the logic is pretty simple. Every some time I will want to spawn an enemy. So what I need for that? First, I need information about how often I want to spawn them, right? So public float spawning rate. Let's start with 2 seconds. Second thing is I need access to enemy prefab. We'll drag and drop it in a second. And do we need anything else? No, I don't think so. Yes, we need reference to all the spawners. So to have that, we can have, yeah, we can do that this way, public and transform, and then spawners, spawn points. Let's call it spawn points. Points. Beautiful. Now we assign those variables before we do anything else. So on this spawners object, first, I need to create the enemy prefab, of course. I forgot about that. So I go to prefab folder and drag and drop the enemy into the prefab folder. Now you see it doesn't have a resetted position, so I can delete it here. I can select it in the folder and then reset its position here. That will fix the prefab. Now I also want the player to be in the center when it starts. So reset, we go back to the spawners and set the enemy, and now we have the spawn point. Let me check if we can do that this way to make it. No, we cannot. Of course we cannot. So we will have to drag and drop one after the other. So we have 14 spawners and we just drag and drop them. There are ways to do that in code, pretty simple, but this way you also see how the list works in the list and arrays work in the in the inspector. Almost there. Awesome, have all of them here. Now what we can do, we go back to the script. We don't need start in that case. Normally we would get those spawn points in start, for example. In the update method, what we do, we check, we need one more variable, by the way, private float last spawn time. So we need to know when the last time when we spawned the enemy. And now, if the last spawn time is lower, last spawn time plus the spawning rate is lower than the time that we have now, right? So we spawned it at certain time plus 2 seconds. So we wait because that's the waiting period. After this, we start to spawn enemy. So first, instantiate the enemy prefab. Awesome. Let's actually call it enemy prefab. So let's call it enemy prefab. Now we need to know the position. So what we do, we want to grab a random spawn point. To do that, what we can do, we grab the spawn points, so all of them, and from them we select random ones. So we use random range from 0 to the last valid index, which is spawn points length. So this is one too much because the length because the indexes start with 0, so we have to remember about that. This will give us a random spawn point. We can use its position, and the rotation doesn't really matter, so we can use quaternion identity, which is like a default zeroed rotation. And this will spawn the enemy. But now, if we don't set the last spawn time, it will start spawning enemies and will spawn them until it kills our computer. So it's important to set the last spawn time to time. And to be fair, I think this is all for spawning enemies. Actually, let's do a small trick. So when we spawn enemy, let's increase the difficulty. So what we can do, we can decrease the spawning rate by some small number. So what we can do, we can multiply it, for example, times 0.90f. So it will be always 98% of the previous value. We test it now. Let's check. Uh-oh. I have an error. Interesting one. When you change the name of a public variable, the value that you put there in the inspector is cleared. So we need to put it once again. Where are my enemies? Over here. Awesome. Yay. Pew, pew. Pew. Awesome. Everything seems to work. Now we have a small problem. I got killed. They kiss each other. That's alright. But if you have a look on the left, we see that the enemies are still spawning. In such a small game, it is not that terrible, but we better handle that. It's good to take care about this type of stuff. So we get here, back to the code, and have to think how we can check if the player is alive. And there is very simple way. Since the spawner and player are always in the scene, what we can do, we can just store the reference to the player. Let's even do it this way. Player, and here we can check if the player is not null, or even otherwise, if the player is null, we can return. That will stop the update method straight away if the player is null. Now what we have to do, we have to bring our player into the inspector input here. So we grab player, drag and drop it, let's save and press play. And let's wait for somebody to kill us. Hello. Dead. So we have 2 enemies and just 2 it is, and they are dancing beautifully. I love it. You see that that's not a bug, that's a feature. Okay, so now we add blood and we are done. Okie dokie, so for the blood we'll need particle system. Particle system, let's call it blood, is basically a spawner of particles. And those particles can be really different things, but in our case they will be just a simple sprite with slight tint of red. Particle systems are pretty complex, to be fair, and just by looking on the right you can see the number of settings they have. So really this is subject on its own, and I think I will make a video sooner or later about them, but today I will talk only about the things that are kind of relevant and important for us. So the first thing we'll need for the particle system, even if we work in 2D, we have to work, unfortunately, with particle systems in 3D, because they are in 3D only. This doesn't cause too many problems, but we have to create, for example, material for them to work. We cannot just assign a sprite to them and have them beautifully, displaying whatever we want. So first, let's create a blood material. I'm creating a folder, materials, just to keep everything tidy. And I create new material. As I said before, material is just an information about how to display something. So here we call it blood, and as you see, there are not that many settings. What's the most important part of the material is its shader. And shaders, again, are pretty complex. They are even more detailed way of saying how to display something. But in our case, we don't need to set up too many things. We just need to select the right shader. We can find it in the universal rendering pipeline, render pipeline, sorry. Then we look for particles and lit. And you see that's all the settings we have. So what's important for us is the surface input, and we'll need for that circle. Let's have a look if we have some circle there. Yes, we have a knob, but this is not that nice. So what we can do, we can go to sprites, click right mouse button, create 2D sprites and circle. Let's call it blood. Now we have beautiful sprite that we'll use for our material. We go back to the material, we select the base map. Yes, our beautiful circle. Now we change its color to something red, maybe a little bit darker. Awesome. And now, as you see, even though we selected circle, it's displayed as a square. That's because at this moment it does not use transparency. That's because the surface type is selected to opaque. We can change it to transparent and suddenly everything becomes beautiful. Awesome. And this is really all we have to set up here. Pretty easy, right? Let's get back to our blood particles. We scroll to the very bottom to the render section, and in the render section we drag and drop our new material. You see, straight away looks much better. Let me have a look if there is something interesting for us in the render section. Yes, we have the let's assume we want them always on the top. So for that, let's create another sorting layer. Front. Awesome. Let's get back to the particles, select front. That will make sure they are displayed on top of everything. And now let's the fun begin. First thing we want to go to the emission. And instead of having rate over time, so continuous release of particles, we want a burst. So here we have burst section, we click plus, we want, for example, I don't know, 15 particles at the very beginning to be spawned. Now we don't want them to last for that long, so we want the duration of the circle to be something very short, maybe 1 second. We'll see in a second. Then start lifetime, so that is how long individual particle will live. And for that, we don't want one constant value because this will be pretty boring, you see. So what we can do, we can click this small arrow here and select random between two constants. And now we can select something between half a second to 1 second. And this is straight away much more interesting. Similarly for speed, we can select here random between two constants and maybe start with 1 to 3 or 5. Or maybe let's even make a shorter life, so something up to half a second. And the start speed, let's make it bigger, so something from 3 to 8. That looks better. Maybe even 12. No, 8 was okay. And maybe 5 to 8. Yep, I like it. Now, we also want to randomize size. So here we have the start size and we do exactly the same thing. So maybe from 0.2 to 0.5, now too small. So from 0.5 to 1. Yep, that will work. And now the last thing, which will be pretty amazing, is the size over lifetime. So here we check the checkbox to enable that feature. And here we have curves. So you see suddenly it looks strange because it's becoming bigger and bigger. We want the other way around. So we want it to be smaller and smaller and disappear. Whoa, amazing. This will do it. Now, there are some other settings which we could use, but to be fair, I already like the result and I think I'm going to keep it like that. Now, we have our blood particles. One last important bit of it is this looping setting. So we don't want it to be looping. We disable it, so it will play once and done. And now, usually this type of stuff we handle manually, so once the animation is done, we destroy the object, but luckily for us, particle effects have a certain setting which allows us to do that without any code. So here you see there is a stop action, and what we can do, we can destroy the particle effects when they finish emitting and doing stuff. Now let's turn the blood into prefab. Awesome. Let's remove it from the scene, and we need to add it to our enemy and our player. So here, public game object blood prefab. Now when we die, we want to instantiate the blood prefab at our own position, and we don't care about the rotation. The fun part is that we can copy paste it to the, oh, you see we've done that on enemy. We just move it to player, copy paste it to the section with public, and we go back to enemy, grab the instantiation of the blood, player, die. And what's important, you see I do that before destroying the game object, because obviously if you first destroy the game object it will not have transform, so you will not be able to spawn it. You have to remember that the order of stuff is quite important here. So the same way for player. Now you see here I don't use the player, right? So it doesn't matter, but if I would like to access here something from the player, I would have problems. But in general, it is good practice to keep the destroy, unless you have a specific reason, to keep it as low as at the end as possible. And I think we have everything. Let's test it out. No, something doesn't work, of course. Can you guess what? We didn't assign the prefabs. So here we have the player, and we go to the enemy prefab, scroll down to the enemy script, and here as well. We save it and run the game once again. Yay! Yay! This is awesome. So I hope you managed to create that game, and I'm waiting for your feedback about this type of tutorials, because this is definitely the longest tutorial I have ever done, and probably one of the longest I will ever do. So please, yes, let me know if you like this type of content, if you found it useful, if you want to create more games together. I really enjoy this type of stuff, so if you find it useful, I can think about other ways, other games we can create together. If you have suggestions for small games like that, so that's important, they have to be pretty small. We have to be able to finish them within 1 hour, 1.5 hours, maybe maximum 2 hours, but that's a little bit too much already, I think. Please let me know, drop me a comment, drop to our Discord. You're more than welcome to join and enjoy the time with us. So I hope you will have a fantastic day. Love you, and bye.